Hello everyone, welcome to my presentation on IoT-based home automation, a project I developed during my Emertxe internship. In this video, I will explain how the system works, what technologies I used, and what I learned from this project. Mm, Our teachers, mm, N. Lakshmi Daniel, Jay Lakshmi Daniel, and Gurupriya, thanks for clarifying our doubts and explaining everything. Let's start our presentation. Let's look at the table of contents. In this project, we have project purpose and scope, important terms related to project, functional requirements, garden light control, temperature control system, water tank management, user interface using Blynk app, which is available in Play Store for interfacing between IoT, for interfacing between um, phone to mobile to phone to device, simulation results and demonstration and conclusion. In we look at project overview. The main purpose of our internship is to understand and develop the requirements for simulated home automation system using Arduino and the Blynk application. Uh, scope of scope of our project is the entire system is simulated using PICSIMLab. No real-time hardware is used. The project focuses on controlling simulated lights, home temperature, and water tank levels. All remote control is managed through the Blynk IoT mobile applications. Uh, the key technologies simulation environment PICSIMLab controllers. We use Arduino Uno for simulation of our program code. Uh, and IoT platform we use Blynk mobile app and cloud server. The entire setup is simulated using PICSIMLab, so no physical hardware was required. And, and our project aims to design a simulated smart home system using Arduino and Blynk IoT application. Let's look out. Let's look out. What is IoT? IoT, it is also known as Internet of Things, connects everyday devices like lights, fans, and water tanks to the internet, allowing us to monitor and control them remotely using mobile or web apps. Mm, that are embedded with sensors, software, and other technologies for the purpose of connected and exchanging data with other devices and systems over the internet. These objects can range from common household items like light bulbs, thermostats, and refrigerators to sophisticated industrial machinery, medical devices, and even entire city infrastructures like traffic light and environmental monitors. The core idea is to give everyday item digital intelligence, allowing them to communicate and interact with each other and with us, often without human intervention. Let's look at let's look at what is Arduino. Arduino is a microcontroller board that allows to read sensor data and control devices. It is easy to program using embedded C++, and it forms the backbone of most of IoT prototypes. We also Arduino is an open source electronic platform based on easy to use hardware and software. It consists of a physical programmable circuit board, often called a microcontroller, and a piece of software or IDE, integrated development environment, that runs on our computer. You use the IDE to write and upload computer code to the physical board. The Arduino board can read inputs like lights from a sensor, a finger on a button, or tweet and turn it into an output such as activating a motor, turning on an LED, or publishing something online because of its simplicity, flexibility, and low cost. And it is incredibly popular with hobbyists, artists, designers, and students for building a wide variety of interactive electronic projects. IoT-based home automation solution. This system connects various home devices through the Blynk app and Arduino. Here, what components used for garden light control. Uh, it is used for adjusting light based on sunlight using an LDR sensor. Temperature control. We use also temperature control. It uses an LM35 sensor to manage heater and cooler operations, automatically switching off it exceeds safe levels. And we also use water tank management system for monitor the water level using a simulated tank and automatically controls inlet and outlet valves. The entire framework demonstrates a complete of IoT loop where an Arduino processes sensor data and executes commands sent from a mobile app, creating an intelligent and automated home experience. Let's look out representation. We see block diagram. We see the figure. We have home and Arduino board using PICSIM software and the Blynk cloud server and mobile app. There are used to interlink between both of everything. It's a feedback system which from home to Arduino to Blynk, Blynk to Mo- Blynk app, which is available in Play Store. We used to change or vary the controls by using Blynk app to change the outputs in their home for application purpose by using Arduino, you know. Sorry. And we also learn C and C++ foundations for IoT in this internship. I gained a comprehensive understanding of both C and C++ programming, which is foundational to the project. I learned and implement core decision making logic using control flow statements like if, else, and manage data with arrays. The training on functions and pointers was crucial for writing modular, efficient, and stable code which is necessity in memory constrained embedded systems. Furthermore, the introduction to C++ and its object-oriented programming OOPS concept sorry, principles was directly applicable as the Arduino environment is built on C++ and interacts with sophisticated libraries that uses classes and objects. This knowledge enabled me to effectively use pre-built libraries and understand the structure of modern embedded code. Garden light control. The garden light control system is designed to simulate the automatic adjustment of garden lighting in response to the availability of sunlight. The system primarily inputs is an LDR. LDR means also known as light dependent resistor, which is dependent to the light for varying the resistance values. It is LDR is also known as sensor, which is used to measure the ambient light. The central process involves an Arduino reading the value from the LDR sensor. Based on the sensor reading, the system then varies the brightness of an LED, which in the simulation represents the actual garden lights. Therefore, the final output of the functional requirement is the controlled illumination of the garden lights, which brightness or dims according to the nature light conditions detected by the sensor. Let's look at the block diagram. We have Arduino Uno, which is connected to lights, and LDR sensor is connected to Arduino Uno. It has input for the Arduino Uno and the output of Arduino Uno is lights. So LDR sensor is acting as input to the Arduino Uno and the lights are acts as output from the Arduino Uno. Temperature control system. In temperature control system is designed to simulate home temperature management using heating resistor, an LM35 temperature sensor and a cooler. The system continuously reacts the temperature from LM35 sensor and displays the value on both on a local CLCD and gauge widget within the Blynk IoT Mobile App. Users have manual control to turn the heater and cooler on or off using dedicated button widgets in the Blynk application. In addition to manual control, the system features an automatic safety threshold. If the temperature reading from the sensor exceeds 35 degrees Celsius while the heater is active, the system will automatically turn off, turn the heater off. Simultaneously, it sends a notification to Blynk app and displays a message to the CLCD to inform the user of this action. We also look block diagram for temperature control system. We have mainly four blocks: Blynk IoT app, Arduino Uno, CLCD, temperature system. Blynk IoT app is used to control the input values for output. Uh, Arduino Uno acts as moderator for acting for operation, CLCD for output to display the whether is heater on, heater off, cooler on, inlet valve is on, inlet valve is off, like that. And temperature system is used for heater control, cooler control, temperature is it gets output is fed back to the Arduino Uno, and like that happens. Water tank inlet and outlet valve control. The water tank control system is designed to manage water levels by reading the volume from a serial tank and controlling the inlet and outlet valves. The system displays the current water volume on both a local CLCD and gauge widget within the Blynk IoT app after reading it via serial communication. Users have manual control over the inlet and outlet valves through dedicated button widgets on the Blynk app. A chance in valves through dedicated button widgets on Blynk app. A change in button's logic level prompts the system to send commands via serial communication to turn corresponding valve on or off. Furthermore, the system incorporates automated controls such as turning on the inlet valve automatically if the water volume drops below 2000 liters and turning off the inlet valve when the tank is full, with notification for those events sent to both Blynk app and CLCD. We also look the block diagram, how the operation was done by water tank inlet and outlet valve control and temperature, everything of our project by simply looking at the block diagram. We use Blynk application. The Blynk application is a platform designed for the Internet of Things that can control hardware remotely, display sensor data, and visualize it. In this project, it functions as primary user interface where various widgets are created on a mobile application to manage the simulated home automation system. Specifically, button widgets are used to control the heater, cooler, inlet valve, and outlet valve. Gauge widgets are utilized to display the temperature and the volume of water in the tank. Additionally, terminal widgets are implemented to display notification whenever a predefined threshold is crossed, showing messages such as temperature is more than 35 degrees, turning off the heater, and water level is full. We can see these are the buttons for heater button, cooler button, inlet, outlet. It is a gauge for temperature. It is the gauge for volume of the water from 0 to 3000 liters, and it is the temperature for 0 to 100 Celsius. Like that, we have to see in mobile app to know what's current temperature and volume of the water as there. The serial tank is a simulated component within the PICSIMLab environment that represents a real-time water tank. The system interacts with this component by sending commands via serial communication to read current volume of a water it contains. The volume data is then used for both monitoring and controlling purpose. It is displayed to the user on a CLCD and a gas widget in the Blynk mobile application, and it serves as input for both system automated logic to control the inlet and outlet valves. Here we see the serial tank, which is used for water level management. It acts as inlet and outlet valves. From this, the water will drops to the tank. Key learning outcomes. C to Arduino. Um, by using embedded C++, transitioned from standard C programming to the Arduino environment, learning to use hardware-specific functions, digital write, analog read, and libraries instead of pure register manipulation. Hardware abstraction. Gained an understanding of how the Arduino framework simplifies complex hardware interaction, allowing for rapid prototyping. Event-driven programming. Learn to implement an event-driven model using Blink write function where code executes in response to user actions on the app rather than in a simple linear loop. API and library integration. Acquired practical experience in integrating third-party libraries, example Blink, Wi-Fi, and using their APIs to build complex features like cloud connectivity. IoT system architecture understood the end-to-end flow of an IoT application from a sensor LM35 and controller Arduino to cloud platform like Blink server and a user interface for mobile app. Simulation and debugging utilizes PICSIMLab for development and testing, highlighting the importance of simulation in embedded system. Uses serial communication and CLCD for real-time debugging. And we see the conclusion of our project. The project has successfully achieved its goal of simulating a comprehensive home automation system by leveraging the Blynk IoT application in conjunction with PICSIMLab simulator. A key aspect of the simulation was representation of real-world objects using simulated components. An LED was used to resemble a light. A temperature-based acts as a heater and cooler, and a serial tank mirrored a real-time water tank. The CLCD served as an integrated dashboard for displaying system events. Within the simulation, the Blynk application provides the user interface for remote control and monitoring. Button widgets were used to control the heater, cooler, and the inlet and outlet valves. Gauge widgets were used to visually display the current temperature and volume of the water. The experience enhanced my skills in Arduino programming, IoT architecture, and cloud connectivity. It demonstrates how IoT can make homes smarter, safer, and more energy efficient. Uh, and finally, the project successfully simulates a real-world home automation system. And we thank you. And we look our project implementation demonstration of our project. Let's look out our demonstration of our project, how it's done. Firstly, this is our code in Arduino Uno. Here are the different types of programs which has home automation blink control .i1o, ldr.cpp file, and ldr.h file, main.h file, serial tank.cpp, serial tank.h, temperature system.cpp, and temperature system.h. In this codes, we have declared some functions. By these functions, we used to implement in main home automation blink control.i1o. This These three codes are template ID, device name, and authentication token are provided by the Blynk.cloud um, from Blynk software, Blynk website. And this is my ID and authenticate device name and token, which is used to access our specified token. Every project has unique token should be there to done their project. We have we include spi.h, ethernet.h, and we have some include some libraries for our program. We see that temperature system.h for temperature, wire.h for wiring, and main file everything. We use bool data type for heater switch, inlet switch, outlet switch, and cooler switch, and also blink timer. This function is called every time the virtual pin 0 start changes to turn on or off cooler based virtual pin value. Blink write is used to write the function for cooler virtual pin and read the changes values on the pin. Based on the pin values controls the heater and cooler. We using simply if else statement. Uh, this is used for displaying on LCD this number of volts and the line. This indicates number of volts. It indicates the line. 0 indicates first line. 1 indicates the second row of a LCD display, and it prints this message when this part of thing executes. It executes this, or else it executes this. Same this type. We have heater virtual pin, and inlet inlet virtual pin, inlet wall pin, and outlet wall pin. And we have void update temperature reading, for uh, to display temperature and water volume as gas on the Blink app. Send temperature to Blink on V1. Like we have this code, we write this code. If volume of water more than 2000, the inlet valve is off. This condition explains that. Here we initialize some LDR temperature system and connect Arduino to Blink Cloud and initialize the CLCD by using some functions we used to declare here, and initialize the serial tank. Update temperature on Blink every second, cannot send more 10 watts in 1 second. In earlier CPP has several programs. We have main.h file. It's defined on when button is 1 and define off when 0. We define the switches. Temperature gauge has V1. Cooler V pin virtual pin has V2. Heater virtual pin has V0, and water volume gauge V3. Inlet virtual pin V4. Outlet virtual pin V5, and blink terminal virtual pin has V6. Yes, it is the serial tank.cpp file, and it is the serial tank.h file. It is the input digital, sensor digital, and sensor analog some functions program, and temperature system.cpp file. In this we have pin mode, heater comma output setting, heater and cooler GPIO pins has output pins, and this function is used, and this line is used for read the temperature sensor and returns the temperature, and cooler control And cooler in this function receives the state of the button on the mobile Blynk app. It turns on cooler, assign digital value 1 to cooler GPIO pin, same as heater control pin. Turn on heater, assign digital value 1 to digital GPIO pins. Temperature.system.h file. This heater for heater button we select 4, we assign 4 pin, and for cooler we assign 5, and temperature sensor we select A0 analog pin. Assign. So let's check our program if have any errors. Let's also check the export compiled binary. We have no errors of our program. So we have to open PICSIMLab. We close this we close this Arduino Uno tab to understand better because there is no errors on that code. So we take load hex file and we load the hex file of to our project. Here we have LCD display and LED and LDR and Ethernet Ethernet section and temperature gauge for cooler. It's for cooler. Um, we see when resistance is high, the light is automatically turned on. When the resistance is low, the automatically the lights turn off. It's for sunlight purpose. When light also when light changes its state by applying the sunlight, and it is the LCD display for displaying the temperature values and the values of volume of water like that. We also open the serial tank to let's wait. Let me. I will show. I will put. Wait. Okay, and I opening my mobile phone to show Blynk app to control the input values from my phone and controlling outputs of in Pixim spare parts. Yes. Sorry. When I turn heater on, let's see here heater on. Here indicates the heater on and gradually increasing the temperature. We see that 28.32, 28.81 like that, gradually increasing the temperature. We see in here and also in Blynk app. We can see that gradually increasing the temperature. We see that 33. We see the change in temperature when the heater on, and the temperature is suddenly turned off as per our program for 35 degrees Celsius. It's let's see, it's automatically turned off and the temperature decreases gradually by using cooler on. When I turn on cooler on button on my Blynk app, here we can see the temperature gauge, like this fan is rotating. It indicates the cooler is on and the temperature it starts decreasing to maintain the temperature cooler. We also see here cooler on the display, and yes, I make turn off this cooler on, and we see this LCD. Then earlier low resistance value, then the light is off, and high resistance value, the light is automatically turned on as per our resistance values. When medium, the light is moderately on. When the resistance is very high, the light is glows very brightly. And we see this tank volume of the water by applying inlet valve on, it's automatically filling the tank. Here we can see that, and also increasing the volume of the water. See that here and there. Our total capacity of the water is 3000 liters. We mentioned in this program. Um, by we control the remote tank um, by using this virtual serial port virtual serial port tools. Here we connected COM1 to COM2 as the inputs and output, and we have so many here for according to applications. We selected local bridge here. We have so many like remote bridge, serial port servers, script ports, TCP IP ports, remote serial ports, etc. But according to our requirement project, we used to select local bridge like we did, sorry, and we I turned off the inlet valve off and I'm selecting outlet valve on. Here see outlet valve on. This gradually decreasing of the volume of the water as decreasing from 3000 to, we can see the values was changing. Sorry, see volumes of the water changing to 1900. We have to put 900 liters as cutoff. Sorry, like that. We also see the display in inflow on and outflow off like that in this display. And this is our home automation project. Sorry, this is our home automation project done in I done in Emertxe IoT internship. And thank you, thank you.